In this video, I'm going to show you guys how to do problem number 1 on the blue sheet, which is the homework over the weekend. So problem number 1 says we have a sample of oxygen gas. It has a volume of 150 liters at a pressure of 0.947 atmospheres. And then what will the volume of the gas be if the pressure is 150 millimeters of mercury? So we are given 2 pressures and we're given 1 volume. So if you look at your notes from class the other day, you'll see that we need to use Boyle's law. Boyle's law is P1 V1 equals P2 V2. And you know we need to use that because we're only given pressures and volumes. We're not given any temperatures. So let's set this up like so and find what we have been given in the problem. Our first pressure was 0.947 atmospheres. And then we were also given 150 liters. All right. And then we're given a second pressure of 1520 millimeters of mercury. And then we don't know our second volume. Before we can plug the numbers in and solve, hopefully you're noticing that our pressures are in different types of units. They have to be in the same types of units for you to complete the problem. So let's go ahead and take the second pressure and convert it to atmospheres because that's an easier conversion. Plus it's kind of nice working with smaller numbers. So the magical number for converting atmospheres to millimeters of mercury is 1 atmosphere equals 760 millimeters of mercury. This is just kind of a reference number. I'll give it to you on a test, but you have to know how to use it. So 760 goes on the bottom so that the millimeters of mercury cancel out, 1 atmosphere on top, and then if you do that math, you see that it's 2 atmospheres. Okay, now we're ready to plug our numbers into Boyle's law formula, which was right here. So our first pressure is 0.947 atmospheres. And for some reason, the paper just flipped over. There we go. 0.947 atmospheres. And we're going to multiply that by 150 liters. And then we're going to set that equal to our 2 atmospheres and then our V2. So you're multiplying 0.947 atmospheres times 150 and then dividing it by 2 atmospheres. You're dividing both sides by 2 atmospheres. All right, so plug that in, and hopefully what you see in your calculator right now is 71.025. Let's go ahead and round that to 72.03. Put liters after that, box it on up. There is our answer. Always a good idea to go back and make sure your answer makes sense in one of these types of problems. So pressure and volume, their relationship is if one goes up, the other goes down. That's called an inverse relationship. So our pressure definitely went up. It went over a little more than 2 times. So our volume should have gone down quite significantly, and it did. So we're done. Bye.